In this video, we want to determine if a relation is a function. Determine if a relation is a function of x. And if it is, we want to write the domain and the range. And the idea here is that every point in the domain, the first set is the domain, and the second set is the range. Every element in the domain is mapped to exactly one element in the range. And for example, here you see how -2 has two arrows leaving -2. That keeps it from being a function. So in this case, we will say this relation here is not a function because -2 is mapped to 1 and 3. Okay, you see how 0 is mapped to -3 only, 1 is mapped to 4 only, and 3 is mapped to 1 only. So that's what we want to see. We want to see what the 0, the 1, and the 3 are doing. What is happening at -2 keeps it from being a function. Okay? And we only worry about what happens in the domain. A function is determined only with what happens in the domain. So let's look at the very first problem, A. We have -2 that corresponds to 1. So if we want to create the same picture, do you see how -2, here it is, corresponds to 1. -2 also corresponds to 3. And then 0 corresponds to -3, and so forth. And I don't even need to continue with the rest of the points because I have a problem here. -2 already corresponds to two numbers, 1 and 3, and we cannot have that. Every point in the domain must have exactly one arrow leaving it. So this is not a function. Okay? On letter D, we have, I will follow the same picture if it helps. This is domain, this is range. Point 3 is mapped to -1. Point 3 is mapped to 4. And point 2 is mapped to 4. The problem here is point 3. It has two arrows leaving it. So that keeps it from being a function. This is not a function because point 3 has two arrows leaving it. Again, we are not concerned with what happens in the range. So you see how point 4 has two arrows ending up into it. That's not a problem for a function. We are only concerned with what happens at 3 because that's in the domain. Now, for the other two problems, we can look at it in a different way. We can use the vertical line test, which says that no vertical line intersects the graph in more than one point, which is again the same idea of mapping. So if you look at the letter B, at the picture on letter B, there is a vertical line here, right there, that crosses twice this point and this point. So anytime you can find a vertical line that crosses more than once, that relation is not a function. Okay? And on the last one, I'm going to use the vertical line test again. I will draw a vertical line, and you can draw the vertical line anywhere. So here is the vertical line I'm drawing. And do you see again how the vertical line crosses the graph twice, once here and once there? Again, we cannot have a vertical line cross the graph more than once. So this is not a function.